Hello, this is Will. I'd like to welcome you to a new series I'm very excited to start. I've been thinking about for 12 or 13 years about making this and finally going to get started. And the series is called From Bronze to GM in miniKanren, which is maybe a strange sounding title if you know what miniKanren is. If you don't know what miniKanren is a purely relational constraint logic programming language, usually embedded in a host language, which is often Scheme or Racket. If you don't know what any of those words are, I'm not sure why you're watching this video. Maybe the video series has become so popular that you're referred to it. And okay, well, there's another programming language, Scheme, that we're going to use in building up to miniKanren. So maybe you want to learn Scheme. Maybe that's why you're here. Maybe you want to learn about how I, as an academic researcher, think about programming languages and programming language design and domain-specific language design or whatever. Could be a number of reasons you're here. Maybe you like some of my other videos and this is like a comfort food video series for you and you just want to hang out. Okay, that's fine. Any of those reasons are fine. But I'm assuming you're here probably because you want to learn more about miniKanren or want to learn about academic programming language research. Okay, because that's really what this series is about. So what we're going to do in this series is we're going to learn miniKanren, and that also means learning Scheme. But we're particularly going to learn to think about miniKanren from a research perspective. Okay, the whole point is to think about these things in a different way than if we were just, say, learning as an undergrad or picking up a book that's like a tutorial introduction. We want to get to the point where we could actually pick up a research paper, implement ideas from the research paper, assess the research paper, understand how that research paper fits into the literature and existing work on, programming languages or whatever, or logic programming, functional programming. Be able to extend the ideas in the paper or mix and match ideas from that paper with other things that we know about. Implement ideas, extend ideas, play around with things. All those sorts of things to the point of writing up original research, communicating original research, giving talks about what we're exploring, trying to assess whether or not what we've come up with is actually new. Or how is it related to other things? All those things that researchers in programming languages actually do. So that's what we're going to talk about and work up to. So I am going to teach Scheme and I am going to teach miniKanren, but it's going to be from that perspective. And this is a different perspective than this is an introduction to programming course, okay? Or this is, you've never seen functional programming, you've never seen Scheme. Here's the beginner's tutorial. This is a different perspective, okay? The point is we're going to get up to research. And everything we do will be from the standpoint of research. So if I'm showing you something, that's because that could be useful for research. Or if I'm showing you something, whatever it is, I'm going to be talking about it from the perspective of research or how I would think about it, how I personally think about it as someone who's been doing research in programming languages for 20 years or whatever. Okay, so that's the perspective. And we're going to work our way up to the point where we're reading papers and we're, thinking about papers and what do we like about a paper? What don't we like about a paper? How could it be extended? And doing research. And so, I'm going to get to the point where I'm showing you things that I'm actively working on as research. Okay? So that's the perspective. Now, why is it called From Bronze to GM? That's a pretty strange title. And the reason is that the approach I want to take, and the thing I've been thinking about doing for a dozen years or more, is heavily influenced by how the StarCraft 2 community of gamers learns and teaches. So StarCraft 2 is a video game created by Blizzard, and it's a long, there's a long series of what are called real-time strategy games from Blizzard, starting with Warcraft, and then Warcraft 2, StarCraft, Warcraft 3, StarCraft 2, and then World of Warcraft came out of that. And it turns out that lots of other video games, actually have their beginning in the history of these real-time strategy games. So League of Legends, for example, could be tracked back to a custom map in Warcraft 3, which was actually a variant of a custom map in StarCraft 1, which is also often called Brood War. But more importantly, okay, so I could talk about real-time strategy games a lot and about their history. I mean, there are two things you should know about StarCraft from the purpose of this these videos. First of all, is that I absolutely love StarCraft and StarCraft 1 and StarCraft 2 and real-time strategy games. I've been playing them since before that term even existed. I've been playing real-time strategy games since 1989 probably, or 1990. There was a game called The Ancient Art of War by Broderbund, which was sort of like an early precursor of real-time strategy games. And I've been playing StarCraft 2 since at least 1999. StarCraft 1 since 1991. 1999. Okay, sorry. I'm stumbling over all these days. I've been playing StarCraft from either 98 or 99. But for over 25 years, over a quarter of a century, I've been playing that video game. I still play it. And I've been playing StarCraft 2 since it came out in 2010. So a real-time strategy game is a multiplayer game where instead of having taking turns like in chess or Go or something like that, all the players are moving simultaneously and the game is played in real time. It's not like, there's a turn and then everyone moves at once and you have 30 seconds for the turn. It's like, no, everything's happening all the same time. Okay. So if you can move faster, you can do better. So you are controlling units. StarCraft 2 is a military science fiction, real-time strategy game. It's largely inspired by the movie Aliens from 1986, the James Cameron movie, where you have, space marines fighting these bugs, xenomorphs. So you're either moving your marines around or your bugs around, and those units can only move at a certain speed and have certain abilities. But because you're controlling many of these units and you're also controlling buildings, you're building buildings that create these units, and you're sending units out to scout. You can only see part of the map at once. There's what's called fog of war. There are all sorts of aspects of these sorts of games that tax your ability to do many things at once. You're doing extreme multitasking, and as you have more and more units on the game on the screen or that you have to control, you can only see part of the screen at once, by the way. You have to play faster and faster. So this notion of APM, actions per minute, and really good players can play 300, 400 actions per minute. For StarCraft 2, I think at my fastest I was in low 200s actions per minute. So anyway, you're playing very, very quickly, and you have a lot of decisions to make. You have partial information. So it's not like chess or Go. You can't see everything at once. You can only see some information, which means your opponent can be bluffing you in various ways. So it's like very strategically rich. It's like chess in that there's a notion of openings that people have figured out, but there's a lot of variability. There's a big difference between the two versions of StarCraft, StarCraft 1 or Brood War, which was the expansion that's what everyone plays. Now there's StarCraft 1 Remastered. StarCraft Remastered is like the updated version of Brood War. And then StarCraft 2. So even those games kind of look the same, they actually play very, very differently mechanically. So it's just very strategically rich. And these are games that have been played for a long time at the professional level. So StarCraft 1 was the first competitive video game that really became popular and started being played as like an e-sport at the point where, in Korea, South Korea, there were 2 television stations, apparently. My understanding is at one point there were 2 television stations that only showed StarCraft. Okay, that was the level of popularity. We're talking early 2000s. And there were professional leagues, and there still are, professional StarCraft matches for both StarCraft 1 and StarCraft 2. StarCraft 1 remains, or Brood War remains extremely popular in South Korea. StarCraft 2 never became as popular in South Korea, but it's still played professionally. And StarCraft 2, which came out in 2010, was the first video game specifically designed to be an e-sport, electronic sport. And it also was coming out at the time where, streaming of video game playing was becoming popular and feasible technologically, where, you had things like YouTube, you had Twitch. Twitch basically came out of StarCraft 2 streaming to some extent. It was originally Justin TV, and it turned out the killer app was people streaming themselves playing video games, and StarCraft 2 was coming out about that time. So with StarCraft 2 in particular, first of all, both of these games are extremely hard. Like, they have the skill ceilings, as people describe them, are extremely high. Okay, so both the speed at which you play, just like the mechanics, the decision making is really, really hard. These games have been described as chess for the highly coordinated. Okay, so you have to understand the strategy of the game, but you also have to play very, very quickly mechanically. So these games are super hard, and if you play them on ladder, you play them online competitively, at this point, the StarCraft 2 players, many of them have been playing since 2010. So they've been playing for 15 years. And for the Brood War players, they've been playing since 1998, maybe. So you're playing people who've been playing the same game since 1998. These people are really, really good. At the height of the StarCraft 1 competitive era, there were professionally sponsored teams that lived in what were called team houses. These were like apartments in Seoul that were set up sort of like barracks with bunk beds and all that, where you had teams with coaches and all that sort of thing. And people would play. They were contractually obligated. If you were on a South Korean team, you were contractually obligated to play StarCraft. I think it was like at least 12 hours a day every day. And, they might have like 2 days off a month. People were really, really good. And because they were living in this team environment, they got very good from learning from each other. And they would share techniques. And each team house would have maybe their own techniques that they didn't want to share with other people, and, that sort of thing. So it developed its own culture. And so it was very intense. Like, people got extremely good at this game. And with StarCraft 2, because you had YouTube, because you had, Twitch beginning and all that, and it was the first game designed to be an esport, you had the players of StarCraft 2 using YouTube, using Twitch to teach each other how to play. So if someone became really good, they might make a YouTube series. And there's a tradition of YouTube series called Bronze to Masters or Bronze to GM, and a number of players have made these series of videos to show you, if you're starting out the lowest level of player, which is bronze, how to get better and how to advance. So online, it's bronze, silver, it used to be copper or tin or something. Yeah, I think it was copper originally, but now it's like bronze, silver, gold, platinum, diamond, masters, grandmaster. And they're different regions. So like there's like the North American region, or the Americas, I guess now, and StarCraft 2. I forget how it's changed over the years, but different regions have their own ladder. And so if you're in Europe, you play different ladder than if you're in North America, and which is different than if you're in Asia, East Asia. So anyway, you start out, when you're just learning the game, you're going to lose a lot because people you play are really, really good. It's like going to a chess tournament or something like that. It's like if you don't play chess an awful lot and study the strategy, you're going to get beat up pretty badly in a chess tournament, right? Like even if you play with your friends and you're pretty good, if you go and you're playing against people who play competitively, even at a medium level and who are actively studying the game, they're probably going to just be way better than you, and then you'll just have to learn over time. It's the same with StarCraft 1 and StarCraft 2. But the difference is that while, say, in high school, when I got into chess, I would read chess books. Now, because StarCraft 2 is a video game, the medium of YouTube, the medium of Twitch, are just like perfectly well suited towards learning and teaching this game. And because it was played professionally, people got good at it, and they got good at it quickly, and people could make careers out of commentating on professional games or casting games, and just streaming themselves playing. And also, people enjoyed teaching the game. So some of the series of Bronze to Masters or Bronze to GM that I enjoyed, there was one from filtersc that was a Bronze to Masters. I learned a tremendous amount there. I learned how to macro, how to make buildings, make units, and spend my money efficiently. That's what I learned there. Apollo or dApollo had a great series where he showed, a lot of it was just him playing games competitively on ladder and saying what he was thinking, to watch someone who had been a professional RTS player just explain their thought process, and scout to see what their opponent was doing, and I saw this, and because I saw that, this is what I'm thinking, So just watching someone high level explain everything they were doing and what they were thinking, that was super useful. Pig has some great series, and I learned a lot from Vibe's series. Vibe has a 2021 series that I think I may have watched an earlier series also from Vibe. The Vibe series in particular kind of shocked me because one of the things about the way someone who's really, really good and who's doing this at the professional level, when they're explaining what they're doing, at some point you start realizing, they just see this totally differently than I do. And it's sort of like if you listen to a super grandmaster talk about chess or how they calculate things, you realize, I know how the pieces move in chess, and I've played lots of chess, but I'm not thinking the same things that they are. They are thinking different things, and they are thinking about the things that I think about in a different way. And that's the sort of thing that's just hard to learn. You may not even know that the things that they're thinking about exist. Okay. And so one of the things that Vibe said was, when you're starting the game, When the game starts, there's a countdown timer now. It goes 3, 2, 1, and then the game starts. It's a real-time strategy game, so time is the critical element. He said the first thing you have to do is click on your main building. If you're playing Zerg, which is what I play, click on your hatchery, press S to select a larva, and press D to create a drone. You need to do that as quickly as humanly possible at the very beginning of the game. Okay? And he said, this is very important. And at first I thought he was joking. And then I realized, oh, yes, to a professional in a real-time strategy game, time is the absolute critical aspect. If you can shave off, a tenth of a second here and half a second there over the course of 5 or 10 minutes, that can add up to maybe a 10-second difference or a 20-second or 30-second difference. That could be the difference between, easily winning a game or easily losing a game. So things like, optimizing actions so that something that maybe would have taken 2 seconds now can take, 50 milliseconds. Trying to figure out how to do that, setting up your hotkeys in such a way that you can do things a little bit faster. So that was very interesting to watch these players who were much stronger than me. Like, how would they think about it? And every player had a different perspective. They thought certain things were important and they wanted to show them to you. So I thought that was super interesting. It was super interesting to watch how these people became good at the game and how they think about it and their different perspectives. And so, and the thing about something like StarCraft, it's like chess and Go. Like, you can see how strong people are because they play each other. They have, basically ratings or ELO scores or the equivalent, which is called MMR and StarCraft ladder. You can see how strong people are, and how people at different strengths play and how they think. Another thing that is interesting is that there's some players who play very non-standard. So Spanishiwa, I think I spelled it right, or CatZ. So there are players who played very non-standard. There's what's called the metagame. Okay, so a metagame. There's the game of chess or checkers or, Go or StarCraft or whatever, and the game has rules. And you learn, that's the first thing you learn, are the rules of the game. But then there's a metagame, which is like, okay, now you know the rules. Now you know how the pieces move. Let's say in chess, you know what the objective of the game is when the game is over, let's say. But how do you go about deciding which moves are good and which moves are bad? How do you develop a sense of strategy? That type of thing. And that's the metagame. So in chess, what are good openings? Or what should your first move be in chess? Like, are there good first moves and bad first moves? Like, how do you decide? If you're in a complicated position, how do you decide to give your attention, or what, do you play in hyper-modern style, or, do you try to control the center of the board by putting pawns in the center, all these sorts of things. And these change over time. Like, as people have different understandings of a game, certain strategies, certain approaches, certain openings will be strong, and then maybe people figure out how to counter those over time, and it evolves. Okay, so there are players that I really enjoy watching. Spanishiwa, who, as far as I know, isn't active anymore, and CatZ. And these are players who would sort of subvert the metagame or change the metagame. So they understood the metagame. They could play standard, but they would also figure out that you could play very differently and still be successful. And in particular, if everyone else is playing according to the standard metagame, if you did something radically different, you could get a real advantage. Like, you could do things that were so weird that your opponent had no idea how to respond because they've never seen anything like that before. So I really enjoy watching these players who somehow they understand the metagame, but they do something different. And also, there have been people who have been important in the history of StarCraft, especially StarCraft 2, and the English casting or presentation of StarCraft, like Day 9, Tastetosis, which is tasteless plus Artosis, and then the like ArtosisCasts videos on YouTube that I've learned a lot from. And Day 9 has made a whole series of videos, made what are called the dailies. That on Tuesdays there were tutorials, okay. On Mondays there was something called Funday Mondays, which were all about subverting the metagame. So on Funday Mondays, the idea is that there'd be some sort of constraint or extra rule that wasn't actually part of the rules of StarCraft, but that you would have to follow. And it would be like absurd sounding, totally absurd sounding. Like, how in the world could you play this video game with this additional constraint and then be successful? But it would always lead to both hilarious games and very strange looking games, but it would also often lead to, oh, maybe you could get away with that in a game. So these were super fun. So the tutorials and the Funday Mondays. Funday Mondays in particular became super popular, and the idea was that people could play along. They could do their own Funday Mondays. And the Funday Mondays, a lot of those constraints remind me of sort of, modern programming language or the evolution of programming, right? So like we had machine code, or, before we had plug boards, and then we went to machine code and then assembly. We had all of this imperative programming, and then we went to structural programming. But in those disciplines, you had a pretty good idea what a variable was. But even with structured programming, maybe you start trying to get rid of global variables, right? You maybe have notions of locally scoped variables. And then for functional programming, you say, well, what happens if your variables can only be set to a value at the beginning and you can never change it again? Okay, so your variables don't vary anymore. And then for logic programming, well, what happens if you don't know what the value of the variable is? You can still use it. And then there are things like symbolic execution, where you don't ever have to assign the value to a variable. You can, just sort of build up constraints around the variables and then solve them. And so there are all sorts of different notions of what a variable is. So, if you only came from, say, BASIC or something like that, which the first language I learned, you had a notion of what a variable is, and you assign to the variable, and if you want to change it, just mutate it and all that. And then, okay, like sort of a Funday Monday from a programming standpoint is, okay, you're no longer allowed to ever change the value of a variable. You can only assign it once. Well, now how do you program, right? So functional programming can be seen as sort of the Funday Monday of, okay, here's a variable, you're not allowed to vary it anymore. Now what are you going to do, right? So it's sort of like there was a meta game that existed, and over time, people figured out other ways to do it. Now, obviously, there's still people playing the game where, they're programming with mutable state and global mutable state. But there are people who are, programming in a totally different style, where it's purely functional or purely relational or whatever. So I find it very interesting to think about things like programming in terms of metagames and subverting the metagames, and what happens when you add this constraint. Now, what in the world can you do? And the first time I saw Lisp, it's like, okay, your programs are all lists? Like, how do you program when everything's a list? That didn't even make sense to me. It took a long time for me to start wrapping my head around it. Why would you want to do that? Same thing with functional programming, same thing with relational programming or constraint logic programming. Like, had to think about things from scratch again. But that's very liberating at the same time. And at that point, you're starting to think really like a researcher. It's like, oh, well, what would happen if we change this fundamental assumption that we've all been using, or that seems to be standard? Like, what happens if we play non-standard and subvert the metagame? Okay, that's basically the job of a researcher in my mind, is to subvert the metagame and play non-standard and play what ifs and explore the design space of programming and programming languages, that type of thing. So I'm super inspired by, and have been super inspired by, how the StarCraft 2 community in particular has learned to play the game, and also how the StarCraft 1 and StarCraft 2 communities, analyze the game, talk about the meta, the level at which people professionally commentate the game or cast the game. All those sorts of things. Like, they've really figured out how to help each other learn. And also there are people who have figured out how to subvert the meta game. And, one of the cool things about Brood War is that game has been played since 1998, I guess. And people are still trying to figure out, so they're still figuring out new ways to play it. They're changing the metagame, even right now, after this video game's been played for 27 years or whatever, and played at a very high professional level for a very long time. So that's really cool to see how the metagame changes. So anyway, this is my inspiration for this idea of a bronze to GM. So bronze is, okay, we're going to start with fundamentals, but that doesn't mean that I'm assuming you've never programmed. That doesn't mean I'm assuming, you don't know what a lambda is or whatever. Yeah, okay. You may or may not know those things. That's fine. But we're going to cover these topics the way I see them, and in particular, the way I see them as applicable to something like miniKanren in a research setting as a researcher. Okay, so even if you've seen Scheme before, even if you took a course in Scheme, like an undergraduate course, even if it was a pretty good undergraduate course, the way I think about these things might be quite different, or what I'm thinking about when I'm looking at Scheme, or why I like Scheme, may be very different than why an instructor chose Scheme for an intro course. Okay, so even if we're looking at the same things, even if we're looking at like Lambda, creating anonymous, functions or whatever procedures, the way I look at Lambda may be different, or the way I think about it, than what you've learned even if you've taken a Scheme course. So that's how we're gonna do it, and we're gonna work our way up to Grandmaster, which in this case means we're doing original research and communicating original research, and also understanding research that exists. Okay, so that should be fun, I think. Another inspiration is a series called The Theoretical Minimum, which is a series of books that came out of a series of courses taught at Stanford, which is basically physics for people who are interested in physics, but, aren't going to study it professionally, or decided not to study it professionally. So, for example, maybe someone who was interested in physics and took physics classes in high school and maybe even in college, but then they went, sort of a different path, and maybe they became a lawyer and now they're interested in going back and learning more. But the cool thing about this series of books is it's not like a popular treatment. It's not, pick your popular science writer and they're giving you like the high level view of things and just making a bunch of analogies. Like, this is actually using calculus and teaching you Lagrangians and Hamiltonians and all those sorts of things. You're actually doing math, and the point is to understand how a physicist looks at these things. And that's quite different from what I learned in sort of an intro physics book. Maybe you're talking Newtonian mechanics and things like that. It's like, well, sure, those could be useful, but there's things like the notion of a Lagrangian, which I certainly didn't learn about when I was first learning about physics, that turns out to be important, not just in physics, but in things like machine learning also. It pops up in many areas. So I really like this idea of, okay, not talking down to the person, but understanding that the reader is coming to this from the standpoint where they're willing to be open-minded and to work hard and think and, experience ideas that are going to be new to them, Some things they've seen before probably, but maybe they're going to see them again from a different light, or maybe they've forgotten some things, whatever. But they're like enthusiastic and they're willing to put in some work. So that to me is super inspiring, and I'm going through these books myself. So that's an inspiration for me. Another inspiration is the apprenticeship model of learning programming languages and writing and all that. So, I did an apprenticeship for my PhD under Dan Friedman, who taught me how to do things like design a domain-specific language and implement it in Scheme, and all sorts of Scheme techniques and tricks and history related to Scheme and different resources, and how to write a paper and how to write a book, all those sorts of things, how to read a paper, how to implement a paper. So that's super inspiring to me. And to me, that was what made grad school worth it, really. That was like my real training in grad school was like that apprenticeship. And so I learned a lot there. But the things I learned are things that aren't really written down somewhere. Like you can't find a textbook, really, that talks about most of those things, and you can't find, like maybe if you got to the point where you could read the scientific papers and you read a ton of them, you would be able to infer a lot of these things, but they're not really taught explicitly. These are more like things that you learn when you're working really closely with someone who's been doing it for a long time. And so it reminded me of the Bronze to GM series with Apollo, where he's like talking about all the things he's thinking as he's playing a game. You just aren't going to find that in like an intro course or a standard textbook or whatever. So, that's the other inspiring thing. So I want to share these things that I've learned, people have shared with me, and not just Dan, but grad students and undergrads, all the people I've worked with, other researchers, hobbyists, professors, all the people who I've learned from, and also from just reading books and papers and all that. I want to try to share those things, and in the sort of informal way that matches my personality and sense of humor and everything and my interests. So here you go. StarCraft is right into, one of the things I love. So that's what I want to do. So things we're going to cover. Well, we're going to cover Scheme. We're going to cover miniKanren, how to read a paper, how to implement a paper, how to, write a paper, how to give a talk, communicating all these things. But they're all going to be contextual, okay? So it's not just, here's a video on how to give a talk. Like, well, we're going to actually try to come up with a talk and all right, here's something we want to communicate. How would we come up with a talk for that topic? Or how would we write the paper? Like, let's write the paper to communicate an idea, do that for real. Those sorts of things. So, and I want to get to the point where if you go through the series, I could have an intelligent conversation with you at the level of researcher to researcher. That's the point, okay? To get you up to the point where you can talk to a researcher in this area, and every researcher is going to have a different background, different perspective, things they like, things they don't like, things they know, things they don't know, biases, misperceptions, thinking that a language or tool or technology is limited because of a misunderstanding on their part that maybe isn't true anymore, or whatever, right? So like every single person is different. It's just like every single person who's done one of these Bronze to GM series on YouTube has a different perspective. None of these people, by the way, are world champions. Okay. So be interesting to see Cyril or one of the Korean pros do this. But the point is that, to me, it's more interesting to see how different players approach the game than it is to have one sort of super player tell you, here's how I play, and oh yeah, I play at 500 actions per minute, so just do this thing. It's like, well, I don't play at 500 actions per minute, so that doesn't really help me that much. It's interesting to see how you play. So I'm coming into this from the perspective of I'm going to show you things I know about, that I think about, okay? But, you know, like I don't like Python that much, and I don't like Java really at all. So I have my own perspective. There are things I like and things I don't like. I like things that are intellectually simple in a way. I like things that are compositional and composable. I like things that are where I don't have to keep a lot in my head. Okay, so I have certain perspective, which I'll share. That doesn't mean that's the right perspective. Okay, language like Rust feels very complicated to me. Language like C++ feels very complicated to me. Those are languages that, you know, I don't respond to intellectually or emotionally or in terms of excitement in the same way that I do to Scheme. miniKanren, you know, sort of the way I use Scheme, the way I use miniKanren very much reflects my perspective. So I will share my perspective. I'm aware that this is not the only perspective and that there are things that from my perspective and personality and the things I like and don't like, you know, that I'm not good at and probably will never be good at. That's okay. You know, different people are good at different things and are interested in different things. But I'll share, you know, my view of this stuff. Is it sufficient to learn, you know, academic PL research from this series? Like, I'm sure no. But I think just like the apprenticeship I had and people who work with me, who've learned under me, it's like it is a useful perspective, right? But you have to learn other things. You need to go read books. You need to take courses. Nowadays, we have YouTube. You can go take a bunch of courses online for free. And, you know, read books, read papers, get lots of different perspectives, okay? But hopefully you'll learn things from this series. You'll learn things that you didn't even know existed, because that's part of it. And you'll learn maybe perspectives or techniques you didn't know about, or maybe you'll understand some things that you were confused about before, and that will help you bootstrap yourself to learn about other things. And then maybe at some point you're like, okay, that was an important step in my development of these understanding these things. You know, I don't really like Scheme or miniKanren that much. I am really into the dependently typed programming languages. Great, no problem. That doesn't, you know, upset me if that's what you decide, if it's helpful to you to get to that point. Okay. So anyway, that is what I'm trying to do. And I'm going to make, hopefully, many videos, because just like the ArtosisCasts, you know, Artosis keeps making these videos of professional Brood War games from Korea. You know, it's like, well, when do those end? Whenever he stops making them. But so far, he makes one every day. Am I going to make one of these videos every day? Almost certainly not. But I intend to keep making them for as long as I can. You know, I intend to keep making these as long as I'm interested in Scheme, miniKanren, relational programming, academic programming languages, you know, sort of subverting the metagame of programming. How long that will be, I don't know, but I don't intend to stop. So as long as I'm in good shape and I can keep doing it, I could do this for a very long time, I hope. So that was one reason I've held off on starting this for so long. It's like, it seems kind of intimidating, right? It's like, all right, this is kind of an open-ended thing that maybe I'll be doing for a very long time. I hope so. I hope I will. Yeah, so that's the idea. And so much for the title. All right. All right. So for my next video, probably I'll talk about Scheme and, you know, start getting into some Scheme, but also I just want to talk about Scheme at a high level and kind of how I think about Scheme and why I find it interesting, so forth. So I am going to do, in some sense, like an intro Scheme section or tutorial. But like I said, this is all from a research perspective, and I'm not going to be afraid of showing you some really advanced Scheme. Okay, so just like with the theoretical minimum, yeah, I'm going to try to build up the ideas, but I'm not just going to show you like intro stuff. I'm going to show you like, okay, here's something that's interesting about Scheme. Here's why you use this. Here's a technique that you can use. So I'm going to assume that you can handle it. If you're confused, let me know. I can try to fill in some of the details, but there are lots of resources. These days you can ask an LLM, here's some code, or here's like, can you tell me about this, right? So between all the resources that are available now, I'm hoping that you'll be able to get yourself unstuck, or, just let me know if something's too confusing and I can, Tutorial Tuesday inspired to try to give more details on it. Okay. And I'm also, I'm going to give exercises and things to do, and, hopefully inspired by Funday Monday also, maybe we can do some challenges and subvert the metagame. So anyway, but we're just starting off for now. Okay. And, I'm still figuring this out, of course. So we'll see how it goes, but this is really what I've wanted to do for a long time. Yeah. Okay. So I will hope to see you soon, and we'll start talking about, I don't know, maybe we'll also talk about miniKanren. I'll figure it out next time. Okay. But we're going to start talking about Scheme and miniKanren and all these other things. Okay. But that's the idea, and that's the inspiration. That's why it's called From Bronze to GM. Okay. Talk to y'all later. Bye-bye.